Hello, here is my 3-minute paper on enhancing antimicrobial peptide productivity in Pichia by improving the fermentation process. The peptide used in this study is cell-penetrating antimicrobial peptide 2, or CAP2. The Pichia strain was known to be a slow methanol utilization strain, and the promoter is OX1, which is methanol inducible. These are some important acronyms used in the following figures. This first figure shows the profiles for the original 4-stage fermentation. The goal of this study was to optimize this existing method to increase the production of the peptide CAP2. And so this original method had 4 stages: the batch, the fed batch, in which glycerol is fed to allow for cell growth, the induction phase, where the glycerol feed is replaced by a methanol feed to induce protein expression, and the production phase, where methanol continues to be fed as protein is produced. The second figure shows the profiles for the improved fermentation method. First, the fed batch method is optimized. As you can see in the original method, the cell growth is exponential, and this is due to the exponential feed strategy of the glycerol. However, a major limitation of this method is that it causes a sharp decrease in the dissolved oxygen level, shown in red. And so there is only so high of a level of cells that can be reached using this exponential growth method. For the improved version, and this figure is just a zoomed-in version of the previous figure, the fed batch phase was split into 2 phases. First was the exponential feed stage, the same as the original version, but after the sharp decrease in dissolved oxygen level, the feed strategy was switched from the exponential strategy to a dot-based strategy. And so the glycerol was fed in such a way that the dot level was maintained relatively constant, allowing for these cells to continue to grow without running into the oxygen limitation of the previous method. This allowed for a dry cell weight after the fed batch stage that was 2.3 times higher than the original method. For the induction phase of the original method, after the dot level decreased, which indicated depletion of the glycerol, the methanol feed was triggered. However, during this original method, a slow induction time and slow response of the dot level was observed. And during the production phase, the dot set point was set pretty high at around 60%, limiting the amount of methanol that was fed, and low methanol consumption rates were observed. In the improved method, the methanol induction phase was split into 2 phases. The first was identical to the original, but in the second phase, the methanol feed strategy was switched over to another dissolved oxygen-based feed strategy. Additionally, in the production phase, the dot set point was set much lower at around 20%, allowing for more methanol to be fed. And in the end, after these changes, a methanol consumption rate of about 1.7 times higher was observed. After all of these changes, the final results were that a final CAP2 concentration was achieved that was 2.5 times higher than the original method, and a productivity measured in milligrams per liter per hour of 2.2 times higher was achieved. These SDS page gels show the confirmation of a protein expressed at the expected size. However, they also highlight one major concern of this method. These contaminant proteins at higher molecular weight, as you can see in the gels, are qualitatively a higher concentration for the improved method, which aligns with previous knowledge that operating at a higher cell density will result in higher concentrations of the protein impurities. Finally, this method was validated by using it for a separate peptide, the CAP3 peptide, and a high productivity was achieved without any further optimization. And so this improved method has been demonstrated to increase productivity for at least 2 peptides, and these strategies may be applicable to a number of other proteins. Thank you for watching.